Hi, we'll talk today about solving power equations. The power equation x to the power n equals to a has solution x equal the nth root of a if n is odd number, and x equal plus and minus the nth root of a if n is even. Just notice, if n is odd, there is no plus and minus. And if n is even, we have to put plus and minus. Let's see some cases. So in case number 1, we have x to the power 5 equals 32. So as you can notice, the power here is an odd number. So we'll just take the fifth root of x to the power 5, and that would equal to the fifth root of 32. And since the power is odd, we don't need plus and minus. So the final solution would be x would equal to 2, because 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Here we have 4, here we have 4. 4 multiplied by 4 multiplied by 2 is 32. And this is the solution for case number 1. So x equals 2. Let me remove this. Okay, let's see case number 2. So we have x to the power 4 equals to 16. As you can notice, the power here is even. So we need plus and minus. So we have x to the power 4, we'll take the fourth root. And here we have 16, we'll take the fourth root of it. But just note here, we'll just remove this and we will add plus and minus. So we'll have plus and minus the fourth root of 16. So this root and this power will be removed. So x would equal to plus and minus 2, because 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, 8 multiplied by 2 is 16. So this is the final solution. Again, we have plus and minus here because we have an even power. Okay, so let's see the next case. So case number 3, we have x to the power 5 equals to minus 32. Okay, as you can notice, the power here is odd number, so we don't have plus and minus. So we'll have x to the power 5 equals minus 32. We'll take the fifth root in both sides. So this power and this root would be cancelled, and x would equal to minus 2. And this is the final solution. Let's see the last case. So case number 4, we have x to the power 4 equals minus 16. Well, we cannot solve this. You know why? Because we are looking for, let me just rewrite it, x multiplied by x multiplied by x multiplied by x equals minus 16. So let's suppose that x is a positive number. So we'll have a positive multiplied by a positive multiplied by a positive multiplied by a positive. That would equal to positive number, right? But if we have negative, let me just write it in another color. So we have negative multiplied by negative multiplied by negative multiplied by negative, that would equal to a positive. So if the power is even, we cannot get a negative number. So there's no solution for case number 4 here. Let's see an example. So we want to solve this equation. So here we have x to the power 2 minus 5 equals to 0. So we will I'll just rewrite it again. X to the power 2 minus 5 equals to 0. I will just sum 5 in both sides. So this 5 and minus 5 would cancel, and we'll have x to the power 2 equals to 5 Now we'll take the square root of both sides. But just note here that this power is even, so we have to add plus and minus here. So we will get, here's x would equal to plus and minus the square root of 5. Here, the power of 2 and the root of 2 would cancelled. Okay, so this is the final solution for part A. Let's see part B. So we want to find the value of x here. So let me just rewrite it. So we have x minus 4 all to the power 2. That would equal to 5. So as you can notice here, we have 2. 2 is an even number. So when we take a square root, in both sides, we have to add a plus and minus here. So as you can notice, the square root and 2 would be cancelled, so we'll have x minus 4 would equal to plus and minus the square root of 5. And we can sum 4 in both sides. So this minus 4 and plus 4 would be cancelled. So we'll have x would equal to plus and minus the square root of 5 plus 4. And this is the final solution. Let's see another example. So we want to find the value of a here. So as you can notice, I'll just rewrite it. A to the power 3 equals minus 8. As you can notice, the power here is odd number. So we'll take the third root in both sides. So this third root and this power would cancelled. So a would equal to the third root of minus 8, which is nothing but minus 2. And this is the final solution. Let's see part B. So we want to find the value of x here. Let me rewrite it. 16x to the power 4 equals 81. I will divide by 16 on both sides. So this 16 and this 16 would cancel, so we'll have x to the power 4 equals to 18, or 81 over 16. Just notice here we have 4, which is an even power. So when we take the square or the fourth root in both sides, we will have plus and minus. So we'll have x to the power 4 equals to 81 over 16. We'll take the fourth root here and we'll add plus and minus, and we'll take the fourth root here. So as you can notice, this fourth root and this power would cancel, so we'll have x would equal to plus and minus the fourth root of 81 over 16. So x would equal to plus and minus, actually we can just distribute this root, so we'll have the fourth root of 81 and the fourth root of 16. And x would equal to plus and minus, the fourth root of 81 is a 3, and the fourth root of 16 is 2. So this is the final solution. Let's see the last example. So we want to find the value of x. So the first thing that we should do, we should add 2 in both sides. So this 2 and this 2 would cancelled. So we'll have 5x to the power 2 over 3, that would equal to 45. Now we'll just divide by 5 in both sides. So this 5 and this 5 would cancelled, and we'll have x to the power 2 over 3, that would equal to 9. Now let me just rewrite it. X to the power 2 over 3, that would equal to 9. Okay, so to remove this power fraction, we have to multiply. So here we have x to the power 2 over 3 all to the power 3 over 2. Why I've done that? Because when we multiply, these two powers would cancel. We will have power of 1. So that would equal to 9 to the power 3 over 2. Why? Because I've already put this here, so I'll put it here too. Okay, so here we'll have x to the power 2 over 3 multiplied by 3 over 2. That would equal to 9 to the power 3 over 2. Here, when we multiply, this 3 would go with this 3, this 2 would go with this 2, so we'll have x would equal to 9 to the power 3 over 2. So, as you can notice, x would equal to the square root of 9 to the power 3. And this is, you can find this property in the Bower's rules. It's a basic Bower rule. So you can just go back to the lesson and study it. Okay, so now x would equal to, since this is the square root, so we have to find the plus and minus. So plus and minus the square root of 9 multiplied by 9 multiplied by 9. And x would equal to plus and minus, here 9 would go out with the 3, 9 would go out with the 3, 9 would go out with the 3. So the final solution would be x would equal to plus and minus 27, because the 3 multiplied by 3 is 9, multiplied by 3 is 27. So this is the final solution. This is the end of the video. Don't forget to subscribe, like, and share the video. And goodbye.